Alrighty guys, so today we're going to continue with our stoichiometry lesson. Today what we're going to be doing is we're going to be learning a different type of problem, and you'll see what that looks like in just a second as we go through the problem. So first we have this problem, very standard. We have our chemical equation, probably not balanced. And so let's always just start off with step one. Step one, we're going to start off by balancing the chemical equation. Step one, we're going to balance. Okay. All right, so what we want to do is we just want to count up how many of each element we have. So on the left side, we have Ca, and we have O, and we have C, and we'll have the same elements on the other side. Now we're just going to count up how many are on the left, the reactant side, and how many are on the right, the product side. So if you look at the calciums, there's no number behind it, so it looks like there is 1. Oxygen, also no number, so 1, and same thing with carbon. It looks like it's just 1 on the left side. If we look on the right side though, for calcium we have 1, and for carbon we have 2, because we have the number 2 behind carbon, and we have another carbon right here, so that means we have a total of 3 carbons. And then for the oxygens we have 1, so we have 1 oxygen. Alright, so it looks like the one that's not balanced is going to be the carbon. There's only 1 carbon on the left side, but there are 3 on the right side. So that means we're going to have to add some more carbons to the left side. Since I have 1 and it looks like carbon is by itself, I can just add 2 more. So 1, 2, then I have 1, 2, 3 carbons, which means that it's balanced out. And so all I need to do is put the number 3 in front of carbons to show that there are 3 carbons. And that's how we would balance out this chemical equation. So this one was pretty easy, but you always want to start stoichiometry problems with balancing. Alright, so the second thing you want to do is you want to find the molar mass of all the involved chemicals. So you want to look for your given, and then you want to look for your end. Okay, so let's start with the given. So it looks like we're trying to look for the grams of each product that's formed in this reaction between 20 grams of CaO. So we know that the chemical, or our starting number, is going to be 20 grams of CaO. And then it tells us there's excess carbon. So since there's excess carbon, we don't need to worry about carbon. If there's excess, we can basically just ignore that chemical. So for the purpose of the stoichiometry problem, we can basically ignore the carbons. Now for the end, this is where it gets a little bit different from what we've been doing. It asks us how many grams of each product. Alright, so if you guys remember, usually in the previous stoichiometry problems, I asked you guys to find the grams of a specific chemical. I might ask you grams of CaC2 or grams of CO. But here it's asking us to find the grams of each product. What that means is you need to find out how many products there are first. So products are the chemicals on the right side, the chemicals that are made. So our first product is going to be CaC2, so we need to find grams of CaC2. And we also need to find grams of CO. So this problem, we're basically going to be doing dimensional analysis 2 times. We're going to do it 1 time, going from CaO to CaC2. So this will be the first time that we do dimensional analysis. But we'll do dimensional analysis second time, going from CaO to CO. Okay, so this will be the second time we do it. So here, because it's asking us to find each product, we're going to have to find how many grams of each product we can make using CaO. Okay, but we do want to start by finding the molar mass, so let's start by finding the molar mass. Okay, so molar mass of CaO, very simple. We just look for calcium. Calcium is 40.08, but I can round that down to 40. And then O is going to be 16, so we can just go on our calculators or do it in our head. The molar mass of CaO is going to be 56 grams per mole. Okay. We also need to find the molar mass of CaC2, so what we're going to do is go on the periodic table. Ca is 40, and then C is 12. So if I want to find CaC2, that means I have 40, and then 12.01, which is basically 12. So C2 is 12 plus 12, which is 24. Oops. So we're going to be basically doing 40 plus 12 plus 12, or 40 plus 24, which is going to give us 64 grams per mole. So CaC2 is going to be 64 grams per mole. And then lastly, we have CO, so we're just going to get carbon, 12, and O. So CO is going to be 12 for carbon and 16 for oxygen. Add them together, and you should get 28 grams per mole. And so there we go. We have step 2. We found the molar mass of all the involved chemicals. So we have 28 grams per mole. Okay, so we did step 2. And now we just need to do step 3, which is the dimensional analysis. Now, the thing about step 3, again, is we're going to have to do dimensional analysis twice because we're going to have to find out how many grams of CaC2 we can make with 20 grams of CaO, and then we have to do it again with CO. So let's start off by doing the first one, so CaO to CaC2. So we're going to write 20 grams of CaO, and then we're going to set up 3 fractions because stoichiometry is 3 fractions. And if you guys remember the sound that you're supposed to remember, you have to remember gmg. Okay, so grams, moles, moles, grams. So gmg. All right, so we just need and we also can remember that the first 2 fractions are about the same chemical. So the first 2 fractions, the tops should be CaO, and then the third and the fourth one will be about what you're looking for. So CaC2, and then CaC2. All right, so now we can start setting up the fractions. So on the bottom of the first fraction, we want to cancel out grams of CaO. So we're going to put grams of CaO. Since we have grams and moles on the same fraction, we're going to get the numbers from the molar mass. So we just look for the molar mass of CaO. If you remember, it was 56 grams per mole. The number next to grams is 56, so I'm going to put 56 on the top. And then the number next to moles is 1. Okay, and that'll let us cancel out grams of CaO. All right, we want to get rid of moles of CaO, so we're going to put moles of CaO on the bottom. For this part, we're going to get the numbers from the balanced chemical equation. So if you look for CaO, there's no number in front of it, which means that it's just a 1. So we're going to put a 1 in front of moles of CaO. CaC2 also has no number. If there's no number, it's going to be 1. So we're going to put 1 next to CaC2. And then moles of CaO are going to balance out or cancel out. Lastly, we want to get rid of moles of CaC2, so we're going to put moles of CaC2 on the bottom here. That way they can cancel out. And then for the last fraction, since it's grams and moles on the same fraction, we can get the numbers from the molar mass. So CaC2 has a molar mass of 64, which is next to grams, and then moles, which is 1. All right, so there you go. Now we just need to plug and chug this into our calculator. So I'm going to go on my calculator, and then I'm going to start off with the numbers on top. So 20 times 1, we can ignore the 1 since it's on top, or since it's a 1. And then so we're going to divide by 56 on the bottom. We can skip the second fraction because it's 1 on the top, 1 on the bottom. So times 1 divided by 1 doesn't really change the number. And then for the third fraction, we'll multiply the number on the top. We'll multiply by 64, and we can skip dividing by 1. So our answer for the first dimensional analysis will be 22.857, and for our units of measurement, it'll be grams of CaC2. Okay? So that'll be our first dimensional analysis. Now, we have to do dimensional analysis a second time because we found CaC2, right? We found CaC2, but we haven't found the other product, and we want to find both products. So we're going to have to find it for CO now. So we're going to set up another dimensional analysis problem, and we're going to start with 20 grams of CaO, just like before. We're going to set up our 3 fractions, just like usual. The top still going to be gamumaga, so grams, moles, grams. We know that the first 2 fractions are about the same chemical, so it's going to be about CaO. And then the last 2 fractions are about what you're looking for, which is CO. So we're going to put CO for the last 2 fractions. And then now we can start plugging in our numbers. So we want to get rid of grams of CaO, so we're going to put grams of CaO. We have grams and moles on the same fraction, so we're just going to get it from the molar mass, 56 grams on the bottom, and then 1 on the top, and then grams of CaO are going to cancel out. We're going to try to get rid of moles of CaO, so we're going to put moles of CaO on the bottom. We're going to get the numbers from the chemical equation. The number in front of CO, it looks like there's no number, so it's just 1. And then we have 1. Moles of CaO is just 1 from the balanced chemical equation. And then we'll cancel out the moles of CaO. If you really want to, you can cancel out the 1s, because if there's a 1 on the top, 1 on the bottom, they can cancel out with each other as well. Or you can just ignore them, whatever works with you. And then we'll put moles of CO on the bottom. Okay, for moles of CO, we're going to go to the balanced equation. For the balanced equation, the number next to CO is 28 for its molar mass, so we're going to put 28. And then for the molar mass of CO, it's just 1 mole, so we'll put 1 on the bottom. And then the moles of CO will cancel out. Okay, and then lastly, we just need to plug this into our calculator. So I have 20, and I'm going to divide that by 56. And then I'm going to multiply that by 28, and that's going to give us the final answer, 10. So it's going to be 10 grams of CO. Okay, so basically what this problem tells us is that, hey, if you have 20 grams of CaO, and then you combine that with excess carbon, you're going to make 22.857 grams of CaC2, and you're also going to make 10 grams of CO. Okay, so this is basically what's happening. Okay, so nothing different from what we've been doing before. It's just that you're going to be doing dimensional analysis twice, or stoichiometry twice, for the same problem. Okay, so hopefully that was helpful. Let me know if you guys have any questions. Again, you just need to make sure you're using the correct chemicals. Usually, it tells you in the problem, though. You're just going to look up. You're just going to look for the products. So usually there's 2, but sometimes there might be more. Just make sure you have the correct chemicals that you're looking for. All right, so I'm in the Zoom call right now. Let me know if you guys have any questions, and good luck on your assignment, everyone.